Welcome again. Now we'll discuss on the part 6 of this chapter 5, which is on the exercise 5b. Okay, the number 1 here, in which of the following situation does the list of number involved make an arithmetic progression and why? Okay, we have to find out whether the given situation involved with the number involved with the list of number, whether they are in arithmetic progression or not, and if it is an arithmetic progression, why they are in that progression. Okay, now with the number 1 here is given that the number of students left in the school auditorium from the strength of 800 students when they leave the auditorium in batches of 20. That means in an auditorium there are students which is about 800. Okay, there are 800 students in that auditorium, and when they came out of that auditorium, they came in batch. That means 20 in the first batch, 20 in the second batch, 20 in the third batch, and so on. Okay, now in answer for this, here the number of students is 800. Let us write this problem or this the whole situation in the form of a table. Now here in the first column we'll write the batches, and the number in the second column we'll write the number of students remaining. Okay, now at the very beginning, at the start, the auditorium is consisting of how many students? 800. Okay, in the first batch, this means in the first batch 20 students go out of the hall, which 800 minus 20 mean the number of students remaining, it will be 780. Mean 20 has moved out of the auditorium. Remaining in the second batch we have 780 left in the room. Now 20 move out of the room. If 20 move out of the room, what is the remaining student in that auditorium? Is 780 minus 20, that is 760. And same thing with the third batch, fourth batch, fifth batch, sixth batch, and so on. It will go on reducing. The number of students remaining in an auditorium will go on decreasing by 20 in each cases. Okay, now if you see here this 800, then is the, if we consider this 800 as first term, second term is 780, third term is 760, fourth term is 740, and so on. We can see that the number of students remaining, they are in arithmetic progression. Why? Because if you find the difference, difference between any two terms, you'll get 20. 780 800 minus this one, you'll get 20, 20, 20, because they are decreasing by the same number, 20. Each instance is being decreased by a number of 20 by the same number. This means it is an arithmetic progression. Since the difference between any two terms is constant, this means you will get only one constant, which is 20, and that number which we are getting is independent on n, that is the number of terms. The first term, second term, third term is independent of this number of terms, but it is a constant between any two terms. Okay, I think you are clear with this. Next we have with the number 2, amount of air present in cylinder when a vacuum pump removes each time 1/3 of the air remaining in the cylinder. That means the air is present in the cylinder. Okay, air is present in cylinder, and when a vacuum removes, each time 1/3 of the air is remaining in the cylinder. That means what is the function of a vacuum pump? That means it sucks the air. When it sucks, each time this vacuum pump is removed, 1/3 of the air is remaining in the cylinder. Okay, let us consider that the volume of air is 1 at the first instant. At the very beginning, let us consider that the volume of air is 1. Okay, then we can represent this whole situation in the form of table here. At the very beginning, the air is 1. At the first removal of this vacuum pump, air remaining is 1/3 of the air present. 1/3 of the air present. At the second removal, 1/3 of the air present. Here air present is 1/3. 1/3 of 1/3 is 1/9. At the third removal, 1/3 of the air remaining. Air remaining is 1/9. 1/3 of that is 1/3 multiply 1/9, which is 1/27. Okay, now if you look at this number, 1 in the first instant, second is 1/3, third is 1/9, fourth is 1/27. Now you try to find out the difference between any two terms, whether it is constant or not. We observe that the progression is in the form 1/3, 1/9, 1/27, which is not an AP, since the difference between any two consecutive terms is not a constant. Okay, now see here how we arrive that is the difference between two terms is not constant. See, 1/3 minus 1, the second minus the first. Second minus the first. 1/3 minus 1. Here LCM of 3 and 1 is 3. 3 divided by 3 is 1. 1 multiply 1 is 1. And then 3 divided by 1 here is 3. 3 multiply 1 is 3. 1 minus 3, you will get -2/3. Okay, the first difference between the first and the difference between the first and second term is -2/3. Difference between the second and the third, 1/9 minus 1/3. LCM of 9 and 3 is 9. 9 divided by 9 is 1. 1 multiply 1 is 1. Okay, minus. Then 9 divided by 3 is how much? It is 3. 3 multiply with 1, you get 3. Now 1 minus 3, it is how much? 3 minus 1 is 2. With the size is greater, is minus. That is -2/9. See, just only in the first, the difference between the first and second, the second and third, you see that is not the same. It's different. -2/3 here and -2/9 in the second. Okay, now if you go to find out the third also, you will get a different value. This means all this difference between the first, second, third and the fourth, they are not the same. It's not a constant. We can say that the given progression is not in the form of an AP. Okay, now the next number we have in number 3. The cost of digging a well for a first meter is 200 and rises by 25 rupees for each succeeding meter. Okay, let us represent this whole situation in the form of table. That the cost of digging in the first meter, cost of digging is 200, and now in the second meter, the cost of digging is increased by 25. That means 200 increase plus 25 is 225. For the second meter that they have to dig the well, it costs 225 for the second meter. For this, for the third meter, the more you go deep, the more is the cost of digging. Now for the third meter, you'll have, now for second meter you have 225 plus 1 meter. That's mean to get the third meter, that means you have to add more 25. This means 225 plus 25 is 250. For the fourth meter also same thing. For the third, up to the third meter, we have 250 plus with 1 meter more, that is 25 more, is 275. Thus we can see that the number are progressing in this way. The first we have 200, second 225, third 250, fourth 275. The fifth will go at with 25 will be 300 and so on. Okay, it will go on increasing in this way. Now we can observe that the progression are every time it goes on increasing by this value, the same value 25. That means if you find difference between these first two, you'll get 25. Between 225 and 250, you'll get the same 25. Between this 250 and 275, you'll get the same, which is 25. Means every time if you subtract two consecutive term, you'll get the same value or the same constant. Hence this situation is in the form of an AP. Okay, the progression is in this way: 200, 225, 250, 275, which is an AP, since the difference between any two terms is constant or independent on n, or n is the number of them. Okay, is constant, therefore it is an AP. Now we have come to the end of this part 6. We'll continue again on the next class.